Hello, students. So now we will start with the next topic, that is law of mass action. What did this law states? This law states that the rate of a chemical reaction is directly proportional to the product of the molar concentration of the reactants at a constant temperature at any given time. Or you can say that the rate of forward reaction is proportional to the active mass of reactants, and the rate of backward reaction is proportional to the active mass of product. The molar concentration means the number of moles per liter. That is called as active mass. So let us consider one reaction. Suppose I'm having a reaction A plus B, and the products A and B are the reactants, and the C and D are the products, and this is a reversible reaction. Now, according to the law of mass action, what I said that rate of forward reaction. Suppose I'm representing rate by R, and for forward reaction I'm writing here F. So what will happen? The rate of forward reaction will be proportional to the active mass, that is the molar concentration of reactants. So these square brackets are presenting the concentration. Whenever I'm writing, whenever we used to write something in square bracket, that means we are representing the concentration. So rate of forward reaction will be proportional to the concentration of reactants, that is A and B. A and B are the reactants, so it will be proportional to the product of the concentration of the reactants. If I want to remove this proportional symbol from here, so I will put one constant over here, that is K, KF, constant for forward reaction. So that is why I have written F. What it is called as? This is called as velocity constant or a rate constant. Now, same I will write for RB, that is a rate of reaction of backward reaction, will be proportional to the active mass of products, that is the product of the concentration of the products. Products are C and D. So I'm writing here like this. Again, if I want to remove this proportional symbol, I need to put a constant over here. This time I have taken the constant as KB. K is a constant and B stands for backward. This is called as rate constant or velocity constant for backward reaction. Now this is the rate of forward reaction, and this is the rate of backward reaction. K and KB are the proportionality constants, which, as I've told you, are called as a rate constant or velocity constant, and they are depends on temperature only. Okay, and catalyst, of course. So what we have said that equilibrium, the rate of forward reaction becomes equal to the rate of backward reaction. Now the value of rate of forward reaction is this, according to law of mass action, and the value of rate of backward reaction is this. So can we put these two values over here? Yes. So we have done the same. Now we will bring kf and kb close, and these concentration on the other sides. So what will happen? Kf upon kb, that is the velocity constant or the rate constant of forward reaction, upon the rate constant of backward reaction, is equivalent to the concentration, the product of the concentration of products upon the product of the concentration of reactants. Clear? Now a combined constant, I have written here a combined constant, that is K EQ. EQ stands for equilibrium. This combined constant K is equivalent to the Kf upon Kb. Any equilibrium constant is equivalent to the ratio of rate of forward, the constant of forward reaction upon the constant of backward reaction. So K, which is equilibrium constant, has a value for the reaction at a given temperature. So according to this law now, the equilibrium constant is equivalent to the concentration of products upon the concentration of reactants at a given temperature. This rate constant, this equilibrium constant can be changed only if we change the temperature. Means it depends upon the temperature only. This is called as equilibrium constant. So the constant ratio, that is ratio of the product of concentration of products to that of the reactants at equilibrium is called as equilibrium constant. If there is no equilibrium, and if at any time, if we will calculate the ratio of the concentration of products and reactants, then that is called as concentration quotient, and we represent that by q. क्लियर, मतलब क्या है कि ये तो इक्विलिब्रियम पर है, इक्विलिब्रियम पर व्हेन वी कैलकुलेट द कांस्टेंट, when we calculate the ratios of the products upon the ratios of the upon the reactant, that is called as equilibrium constant. At any time during the reaction, अगर हम कभी भी प्रोडक्ट के कंसंट्रेशन और रिएक्टेंट के कंसंट्रेशन का रेशियो कैलकुलेट करें, तो दैट इज कॉल्ड एज कंसंट्रेशन कोशेंट, और उसे हम के बजाय क्यू से रिप्रेजेंट करते हैं, ठीक है. एंड वी need to remember this, that q becomes equal to the equilibrium constant when the reaction is at the equilibrium state. जब रिएक्शन इक्विलिब्रियम पर आ जाती है, देन q is equivalent to k. मतलब समझ रहे हो ना कि ड्यूरिंग द रिएक्शन अगर हम कभी भी एनी टाइम, तब इक्विलिब्रियम है या नहीं है, अगर इक्विलिब्रियम नहीं आया है उस वक्त, अगर हम अपने प्रोडक्ट्स के कंसंट्रेशन और रिएक्टेंट्स के कंसंट्रेशन का रेशियो कैलकुलेट करते हैं, तो जो वैल्यू हमारे पास आएगी, दैट इज कॉल्ड एज concentration quotient, and we represent that or we denote that by q. But if at equilibrium we calculate the ratio of the products and reactants, that is called as equilibrium constant, and we represent that or we denote that by q. Okay. Now suppose this is our reaction, any reaction, any simple reaction we have taken here, aa plus bb. These two are the reactants and these two are the products, a b c d. These small a b c d are representing the stoichiometries over here. So what will be the rate of forward reaction will be kf of a, the concentration of a, and these stoichiometries will become the powers of a, and b of b, and rate of backward reaction is kb, c of c, and d of d. At equilibrium, both these, rate of forward reaction and rate of backward reaction, will be equal. So we can write like this, and here instead of rf and rb we can put these values also, and we will get this. So k of equilibrium means equilibrium constant is equivalent to the concentration of products forward reaction upon the concentration of backward reaction. Clear? Now suppose this is the reaction, nitrogen plus hydrogen forming ammonia, and we have to calculate the equilibrium constant for this. So what will be the equilibrium constant? It will be the rate of forward reaction upon rate of backward reaction is equivalent to the, here I think I have written wrong, kf, here it will be द कंसेंट्रेशन ऑफ प्रोडक्ट. सो ये ऊपर आएगा और ये नीचे आएगा, ठीक है, इसे करेक्ट कर लेना. इट विल बी हेयर एंड इट विल कम हेयर. सो के एफ अपॉन के बी इज इक्वल टू द कंसेंट्रेशन ऑफ प्रोडक्ट्स. So this is the concentration of product. We will write here in the square bracket. So it means we are talking about the concentration. Whatever is the stoichiometry. Here it is 2. That will become power upon the concentration of reactants. So reactants are nitrogen. So N2, nothing is here, so power is 1 simple, and H2, here we are having 3, so 3 will become the power. So in this way we can calculate the concentration. Now again one more reaction. Suppose H2, hydrogen and chlorine are forming HCl. So here you can see, students, here we are having gases. So when we have gases, H2 plus Cl2 forming HCl. So here we are having all the reactants and products in the gaseous state. So in gaseous reactions, the concentration of gases may also be expressed in terms of their partial pressures. Like gases have the pressures, so we can represent them in the form of partial pressures also. So what will happen? In place of concentration, we will write their pressures. Otherwise, it will remain same. Means K equilibrium in case of gases can be equivalent to the partial pressure of product upon the partial pressure of reactants also in terms of pressure if we are calculating. So if we are calculating the concentration in equilibrium constant in terms of concentration, then that will be the formula which we have done before. And if we are calculating the value of equilibrium constant in terms of pressure, then we will write the partial pressure of product upon the partial pressure of reactants. and same the stoichiometry of whatever will be the stoichiometry, that will become the power. Clear? What it in that case, that is called as kp. In terms of pressure, if we are calculating, so that is called as kp. And in terms of concentration, if we are calculating equilibrium constant, then we can denote that by kc. C stands for concentration and P stands for pressure. Clear? Now see one more question. PCl5, PCl3 and chlorine Cl2 are at equilibrium at 500 Kelvin and having concentration 1.59 m, 1.59 m of chlorine and 1.41 of PCl5. Calculate Kc for the reaction. So what we have to do, first of all, we will write the reaction. Clear? Then equilibrium constant. We know that equilibrium constant is equivalent to the concentration of products upon the concentration of reactant. So we will put this formula. So the concentration of products and reactants is given to us. So the concentration of PCl3 is what? 1.59. We will write here. The concentration of chlorine is also 1.59. We will write here. The concentration of PCl5 is 1.41. We will write here. In reaction is already balanced and there is nothing as a stoichiometric coefficient. So 1 will be the power in all the cases and we will calculate this. Answer will become 1.79 because we are calculating equilibrium constant in terms of concentration. So we will put M with that. So 1.79 M will be the answer. Now, one more question. What is the concentration, what is the Kc for the following equilibrium? When the equilibrium constant of each substance is this, and this. For SO2, it is 0.60 m. For oxygen, it is 0.82 m. And for SO3, it is 1.90 m. So first of all, again, we will write down the reaction and we will balance the reaction. Balancing is very important. Why balancing is important? Because stoichiometric coefficients are going to be the powers. So that is why it is very important to balance the reaction. Then we will write the formula. According to formula, the equilibrium constant is equivalent to the concentration of product upon the concentration of reactants. All the concentration are given to us. So we will put the values and we will see here SO3. The coefficient is 2. So 2 will become the power. SO2, 2. So 2 will become the power. Oxygen only 1. So 1 will be the power and we will calculate this. So 12.229 will become the value of the equilibrium constant at this case. Clear? So in this way, we can calculate the value of Kc. Same way, we can calculate the value of Kp also. Suppose we are having any question and in that question, in place of concentration, the partial pressures are given to us. Then also we can calculate in place of concentration, we will write the pressure. Otherwise, the formula and the method of calculating will remain same. So in next class, we will do some of the questions related to partial pressures also, means we will calculate Kp also. And after that, we will see what is the relation between Kc and Kp.